Hey guys, so this video deals with quantitative chemistry and IB questions to do with quantitative chemistry. My last video dealt with the molar concept in specific, but this video deals with everything under quantitative chemistry, which does include molar concept, but it also has things like limiting reagent, percentage yield, Avogadro's law, gas laws, all of these things. This video deals with all the IB questions that I could find. These are past paper IB questions, so it'll be really good revision if you're revising for the exams, which I'm sure you are because right now I'm revising for exams, which are in less than 2 weeks. Okay, so let's begin. For the first question, you can see straight away that it's a neutralization reaction between potassium hydroxide solution and aqueous sulfuric acid. Neutralization reaction, gives you a salt and water. Okay? So first thing you do, since you know that they're asking for the volume of potassium hydroxide in this neutralization reaction, you write out a balanced equation. So KOH plus H2SO4 gives you the salt, which is KSO4, K2SO4 plus H2O. Okay, and then you balance it out. So here's a 2 and a 2 here. And you can check that balance and everything should be alright. Then I make myself a little table, okay, and I write down volume here, concentration, and moles. Because in order to compare, you need to convert everything into moles. So let's take all the information that the question gives us and you put it into this little table. So it gives you the concentration of potassium hydroxide, which is 0.2. And it gives you both the volume. I convert it straight away to decimeter cubed so that I don't forget. And 0.2 mole decimeter cubed for the concentration. And X is the unknown here, which is the volume of KOH. So we can actually find out the number of moles of H2SO4 in this experiment. You should know the formula, which is NCV, which is number of moles over concentration times volume. If you don't know the triangle method, which I love and I use all the time, this is basically what it is. Number of moles equals concentration times volume. So here, we can find out the number of moles because we have concentration and volume for H2SO4. So you go 0.025 times 0.2. And this is a calculator. This is paper 1 question. Can't use calculators. So you have to do it by yourself. It's pretty simple. 2 times 25 is 50. Okay? And how many decimal places are there? 1, 2, 3, 4. 1, 2, 3, 4. So 4. So 1, 2, 3, 4. Right? So it's 0.005. Okay, so let's make that neater. 0.005. Okay? This is the number of moles here. And then I taught you that method before. If you have, for example, an equation like this, H2SO4, and you know that the number of moles here is 0.05, and you want to find out here, what you do is you do the cross multiplication method. So the number above or below the variable, the unknown, you multiply, you multiply this way and you divide this way. There's an invisible 1 here, right? So it's 2 times 0.005 divided by 1, okay? Which gives you 0.01, okay? So this is the number of moles here, 0.01. Now, you see that you have 2 of the things in the triangle, moles and concentration, so you can easily find out volume by, so volume equals, you can see here, N over C, N divided by C. So let's take this here. It's kind of messy, I know. So number of moles is 0.01 over 0.2, right? What you can do to non-calculate a question, okay, I know if you're kind of not that great at math, I'll teach you a way to do this. So you get rid of all the decimal places, so it would be 1 over 20, okay, and you multiply it so you get the denominator as 100, so times by 5, which is 5 over 100, and that's easy. 5 over 100 is 0.05 decimeter cubed. Now the answer, all the answers here are in centimeter cubed, so you convert it by timesing it by 1,000, and you get 50 centimeter cubed. Okay, so the answer is C. Okay, now let's move on to the next question. Let's just get rid of this mess. Sorry about that. I tend to be pretty messy, so yeah. Okay, the next question. It's talking about which of the following compounds has or have the empirical formula H2O. Okay, empirical formula is just the simplest ratio of the molecular formula. Okay, so what you do is you take all the C's and you put them together, so C2, and then put all the H's together, H4, and all the O's, so O2. Okay, so you do that for all of them. So here it's already done for you, 6H12O6, C12H22O11, okay? And then you divide everything by the smallest number, okay? So you get, so here everything is divided by 2, so CH2O. Here, also CH2O. Here, it's not. It's this is actually the simplest ratio you can get. So these are the two correct answers, which would be A1 and 2, which is C. Okay. So that was simple enough. Moving on to the next one. Sorry. Okay. For the next question, it says, assuming complete reaction. Again, it's a neutralization reaction, so similar to the previous one, so I'm going to zoom by this, okay? I'm going to do it really quickly. BaOH2. Do it with me and see if you get it right, or you can pause the video and see if you get it right. I don't know what happened there. Okay, so BaCl, and it's actually BaCl. Oh, sorry. BaCl2. I don't know what's going on in the tablet. Okay, so and then you have H2O here, and you balance the equation. You have a 2 here and a 2 here. Okay, so again, you make a little table. So volume, concentration, number of moles, and what you do is you fill in all the stuff. So you've got of HCl, you have 0.2. This is the concentration. You want to find the volume. Concentration is 0.2. And here is, again, straight away, make it into decimeter cube so you don't forget. 0.2 here. Actually, if you notice, okay. Just keep going. And to get the number of moles, again, you do the same thing. So it's, wait, I always have to draw the little triangle. I don't know, I'm dyslexic about that or something. So it's concentration times volume, so 0.025 times 2. This is actually kind of the same equation as last time. It's a different equation, it's the same question though, if you haven't noticed already. It's kind of stupid. Okay, yeah. And then you multiply it here, and again, it's literally the exact same question. It's kind of weird. Okay. And to get the volume equals N over C. So number of moles 0.2. Oh, sorry. Number of moles is 0.01 over 0.2. And you know what that's going to be. It's going to be 50 centimeter cubed. Okay, that was really easy. Moving on. So number 4, under what conditions would 1 mole of methane gas occupy smallest volume? Okay, so you know from the gas laws that it goes PV over T, okay? So I know that they're asking about volume, right? So volume, if you take everything else on the other side, it's actually volume is like that, equals T over P, which means volume is directly proportional to temperature, and it's inversely proportional to pressure. So that means the more volume that you have, the more temperature you have, the more volume you have. The less pressure you have, the more volume you have. And that makes sense if you really think about it logically. It's a really easy concept to grasp. So if you're talking about the smallest volume, you would want the least temperature and the most pressure. Think about it. Think about it logically, and honestly, this is so simple. So you look to all your answers, all your options. You get the smallest temperature, which would be either of these two, and your highest pressure, which would be this one. So it's B. Okay, so that was really simple. I like these questions. Okay, this one's even better. Because it's just asking you to what's it called? It's asking you to balance the equation, and that's really simple. All you do, I never start off by balancing the H's or the O's. I always start off by balancing the other element. So that would be C in this case. So you would need 3 to balance it out. That would mean that on this side you have 6 O's plus 1, so 7 O's, and here you only have 2. So forget the O's for now, let's do the H's then. We have 8 here and 2 here, so let's put a 4 here. So let's see if that balances the O's, because usually when you balance the H, it already balances the O's. So you have 6 O's plus 4, so that's 10. Okay, well, we can manipulate the O's as however we want. So if we put a 5 here, that's already done. Let's see what the question is asking. The question is asking, what is the total of the coefficients of the products? Okay. So 3 plus 4, 7. So that's your answer. I know these are a lot of questions. There's a total of I think 23 questions, so bear with me. Okay, number 6. It's asking you about, again, an equation between HCl and calcium carbonate. So you want to get used to these kind of questions because they come up a lot, okay? So you want to make this little table again. I know, I'm sorry, I'm kind of all over the place with this, okay? And they're asking for the volume of HCl, so you put an X there. It's the variable, you don't know what it is. And then you put 0.5 for the concentration. Calcium carbonate, you put 10 grams. This is, okay, so this is a little bit different. So it's either volume or grams. Okay, so because this one, they're not actually dealing with gram. They're not actually dealing with liquids. It's a solid, so it's 10 grams. Okay. You actually don't need any more information to find out the, I mean you do, but not in the question, to find out the number of moles of calcium carbonate. You know the little triangle thing, okay, which is mass over number of moles times molar mass, okay? What it is you have the mass, 10 grams, okay? You want the molar mass of calcium carbonate. You can add that up. So for calcium, it's 40 plus 12 for carbon plus 3 times 16 for the 3 oxygens, and that's 100. Okay? So to find out the number of moles, it's mass over molar mass. So mass over molar mass, which is 10 over 100. And that's simple. It's a non-calculated question, but you can do that easily, 0.1. And in order we can easily now convert the moles and find out how many moles the experiment actually needed for HCl, which was, you do the little cross multiplication thing, so it would be X, so let's just write it here, CaCO3 plus 2HCl gives 0.1, sorry, what kind of one is that? It's a stupid one, sorry. Let me just get rid of that, okay, and X here. So you take this one, multiply, and divide this one. So 2 times 0.1 divided by 1, because there's an invisible 1 here, and you get 0.2. Okay, so there are 0.2 moles here. Okay, and in order to get the volume, the little, I swear I have to draw this every single time. Okay, so CVN. I always remember this triangle because CV is like a CV, and I just put the N at the top, so that's how I remember it, if you need a little trick. I have these little tricks all the time, so bear with me. Okay, so for the volume, it's N over C, which is, you have N and you have C, so 0.2 over 0.5. Okay, again, for those people who suck at math, like me, I swear I didn't know how to do this before. What you do is you get rid of all the decimal places, so it'd be 2 over 5, okay, and then you multiply it by 20 because wait 1 second. Yeah, you multiply it by 20 over 20 actually. I told you I suck at math, okay? So you get 100 at the bottom, and you get 40 here. So your answer is 0.4, but this is in decimeter. I'm running out of room. Okay, decimeter cubed. Answer is in centimeter cubed. So 0.4 times that by 100, and you get, oh, wait a second. 0.4, sorry, times it by 1,000, yeah. Okay, almost had that wrong there. 400 centimeter cubed. Okay, so your answer is D. Okay. See, they don't give you enough space to write your working. Oh my god. Wait 1 second. Okay. By the way, ignore this little message somewhere here. It's really annoying, I know, but like I didn't pay for the program. Kind of cheap, but like ignore it. Okay. For the next question is number 7. It's asking you what sample has the least number of atoms. Okay, so this is Avogadro's law. Okay, Avogadro's law says 1 mole of anything gives you 6.02 times 10 to the power of 23. Now you have to work out how many atoms for each one of these and compare them. But there's a really, really easy method that takes like no time at all. What you do is you count how many elements are there in each one of these, what are they called? Molecules, sorry. And then what you do is you multiply by 6.02 times 10 to the power of 23. So here, there's 2 H's, 1 S, and 4 O's. So that gives you 4, 6, 7. So 7 times 6.02 times 10 to the power of 23. You don't actually have to work it out. I mean, imagine doing that with a non-calculator paper. Okay, for this one, you have 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 6.02 times 10 to the power of 23. Here you have 4, okay, but you have 2 moles, so you have to go 4 times 2. So it's actually 8 times 6.02 times 10 to the power of 23. For the last one, it's also 4 times 2, so it's 8 again. So immediately you can see, you look back to the question, the least number. I remember when I first did this question, you have to be careful with the wording. When I first did this question, I got so carried away with everything that I thought it was the most number of atoms, and I got really confused. I thought I did something wrong. But it's asking for the least number, which is A. Okay? So, for the next question, it's asking you about which one of these compounds has a molecular mass, a relative molecular mass of 60. So how do you do that? It's going to take a while, this one, but you have to look at the periodic table. what I usually do for this one is first I put it, what's it called? I put all the C's together. 1, 2, 3, so 3 C's. And then how many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 H's. Wait, let me count that again. So 4, 6, 9. Yeah, 9. Okay? And 1 N. Yeah? Same thing here. You put, I keep forgetting how to say it in English. Okay, 1 second. You put all the C's together. In Arabic, you say bitgamma. Bitgamma all the C's together, okay? And then you put the H's together. So you have 3, 4, 5, 6, 7. So 7 H's and 1 O. Yeah? And again here, you put all the C's together. So you have 3. How many H's? You have 3, 4, 5, 6, 7, 8. So 8 H's and 1 O. Okay, you really need to be careful with this because honestly, you get so mixed up and like not counted properly. I have a feeling I counted something wrong actually. Let's go back here. How many H's are there? 1, 2. Okay, wait. 3, 4, 5, 6, 7, 8. I see. I knew it. I could feel it. It's an 8 here. Okay, that's such a bad 8. Okay, sorry. Okay, and I don't know what happened. Okay, so now what you do is you have to multiply like 3 by 12 plus 9 plus n is, you have to look at the periodic table, it's 14. Okay? And you get 59. And here, if you do the same process, 3 times 12 plus 8 plus O, which is 16. Some of these you kind of have to, it's 60. Okay, so that one's right. Again, 3 times 12 plus 8 plus 16. These are the same. Oh, I didn't even notice that. Yeah, 60. Sweet. Okay, so it's 2 and 3, so it's C. Okay, moving on to the next one. Oh, it's on 2 separate pages. Forgive me, guys. Forgive me. Okay, the empirical formula of a compound is C2H4O. Which molecular formulas are possible for this compound? Okay, again, what you do is you gather. Oh, that's the word, you gather. Okay, you gather all the C's together. Okay, C2, and here's H. There's 4 H's and 2 O's. So you know that's not the one. Empirical formula means you divide it by 2. You divide it by the smallest number because you want the smallest ratio, right? The simplest ratio. So it'd be CH2O. That one's wrong. Okay. You can move on. This one's C. 1, 2, 3. Oh no, it's 4. You have to be careful of counting these. I swear, this is what's gonna make me get bad on the exam. Like not counting the H's properly or something, missing one of them. Okay, so there's 3, 4, 5, 6, 7, 8. So there's 8 here and 2 O's. I have a good feeling about this one. You divide it by 2. C2H4O. Is that right? Yeah, that's right. Okay, sweet. So this one's right. And this one should be right because none of the answers are a single answer. The C1. Look at that C. That looks like an O to me. Like if you're skimming by these so fast, you're gonna miss something. So be careful. So 1, 2, 3, 4. So C4. These tricky IB people that are making these questions, I swear they're so tricky. Okay, so 3 and 3 is 6, 7, 8, and then 2 O's, which is the same as this one, so you know it's going to be the same empirical formula. So, there you go. Okay. Wait, it's C? Yeah, it's C. Okay. Next. Alright, okay. Number 10. We're like not even halfway through, so yeah, be patient. What's the total number of ions present in the formula Al2, SO4, 3. Okay, well, it's talking about ions. We know that SO4 is 2 minus, okay, and there's 3 of them, so times that by 3, okay, so there are 3, okay? And Al is also a, what's it called, an ion. You times it by 2, you get 2, right? Okay. Oh, hello. Okay, and you add these two together, and you get 5, so C. That's really that simple. Okay, calcium carbonate decomposes on heating as shown below. Okay. So this question has to do with percentage yield. Okay, it's really similar to all the other questions that we've been doing a million times. Okay, and you have to write down the equation. Okay, CaCO. Oh, okay. O plus CO2. And then you write down everything you have. Here they give it all in grams. So you can write down grams, and then you can write down number of moles. The number of grams here is 50. And the number of grams of calcium carbonate is 7. So what's the question? What's percentage yield of calcium oxide? So it's of this one. Okay, we'll talk about percentage yield in a second. Well, basically, okay, might as well now. Okay, I swear my handwriting is usually really nice. Percentage. Wait, yield. How do you spell yield? Yield. Okay, it is experimental value, okay, over theoretical value times 100. I will explain that, just don't worry, in a second, okay? Experimental value, the theoretical value is always the one that we get. Yeah? Okay. Okay. So basically, what you have to find out here are a few things, okay? You know that the experimental value, as they said, this is the value that they got in the experiment is 7, okay? So 7. This is what they got when they did the experiment. But theoretically, what should they have got? What should they have gotten? My English, oh my god. Okay, what they should have gotten was, okay, you have 50 grams. You need to find out moles first. You need to convert that. So 50, oh my god. Okay. 50 grams divided by, do you remember before we calculated the, what's it called? Whatchamacallit? Thing? The molar mass of calcium carbonate was 100. So the number of moles is 0.5. Okay, ratio is 1 to 1, so 0.5 moles here. And the grams should be, because you times it by the molar mass, which is 40 plus 16, which is 56. And you would get, basically it's 56 divided by 2, right? Which is 28. Okay? So that's what they should have gotten. So 28 times 100. Again, this is a calculator question, guys, so be careful. It's a quarter. You simplify it times 100. You know a quarter is 0.25. Okay, and times it by 100 is 25%. So it's B. Okay, cool, man. Moving on. Okay, I need battery. I have 9%. Okay. I don't know what to do. Okay. For the next question, what volume of sulfuric acid? Okay. They're asking for, okay, so again, oh my god, you do this question again. I'm getting really tired of these questions. Actually, you know what? I'm gonna let you guys do this question. You can pause if you want to pause and check the answer. I'm gonna give it to you in a second. Pause now. Okay, pause. And the answer is B. Okay? Oh no, it's not. Yeah, it is. Okay. So you can do that question on your own because we've done these a million times. We know how to do them. Enough. Guys, seriously, enough. Okay. For the next question, it's talking about ideal gas. Thank God, something different. Okay. So you know that for the ideal gas, what you can do is PV over T, alright? And you're looking for... No, wait. Okay, let me just finish this one question, okay? The pressure's tripled and the temperature is doubled. Okay, they're looking for the volume. So what I always do is I take everything else to the other side, which is T over P, and I find out, it said that the pressure is tripled and the temperature is doubled. So your answer is 2 over 3. Yeah? 2 over 3. Now, okay. Next question. Wait, I'm gonna go change my battery. 1 second. I mean, charge it. 1 second. Okay, so I changed. I recharged my tablet. Okay, I'm pretty sure you guys don't care, but like, yeah. Anyway, okay, so question number 14, right? Let's see, number 14. Oh my god. Okay, so you can see that this is a really similar question again, and I'm not going to do it because it's boring. It's really boring because it's so similar to the other ones we've done. So I'm just going to tell you the answer. You can do it by yourself, so if you want to pause now. Okay, and the answer is B. Okay? You know how to do it. First you have to change it to moles, okay? I feel bad not doing this for you, but like, honestly, it's so repetitive, okay? You change everything to moles. You have the equation, you know, number CV. What does CV stand for? I forgot. CV, okay, and N, okay? Change it to moles, blah, 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 and then you're fine. You'll know the rest from there. Okay, next question, 15. This one is also talking about... Are you kidding me? No, I'm not doing this. Okay, it's such a similar question. Okay, I'm gonna tell you the answer, but I'm not gonna do it, okay? Basically, the answer... Do it by yourself. Okay? Sorry I'm being harsh, but this is ridiculous. 0.2 mole DM3. And if you really can't do it and like whatever, you can message me and I'll walk you through it, okay? I'll send you like a step-by-step type thing. Okay, number 16. Oh, this is a really good question. We haven't gotten so far. It's talking about the empirical and molecular formulas of aluminum chloride. Okay, first we do empirical. Empirical is the formula with the smallest ratio, simplest ratio. Okay, so what you do is I always write down. It's talking about aluminum and chlorine. It's aluminum chloride, right? So I put them separately, aluminum and chloride. And then I write down their percentages. Thing is, okay, we want to find out their moles, okay? And how do we find out their moles? We can find out their moles from their grams, right? How many grams there are. But they're only giving us percentages. We can automatically convert that to grams, okay? So it's really okay. So for example, here it's 20.3. This is grams. And 79.7 grams, okay? And then you want to find out the number of moles. So what you do is you divide this by its molar mass, which is 26.98. It's number of moles. You can calculate that. This is a paper two question, thank God. So you don't have to, you can use a calculator. So 0.7524. And here you divide it by 35.45, which is a molar mass for chlorine. Okay, and you would get 2.2482. Okay? Thing is, this is like, these are not nice numbers. You want whole numbers. So what you do is you divide everything by the smallest number you have, which is this one. So, and here, 0.7524. and your answer should be 1 here. This is the ratio, okay? Your answer should be 1 here, and 3, is it 3? Yeah, it's 3 here. Okay, it should be like 2.99 something, but basically it's 3. Okay, so your answer, this is the empirical formula, your answer is AlCl3. Did you get it? Now it's asking for the molecular formula. Basically, how do we get that? Okay, I have to scroll up, but it's, or whatever, I'll just do it here. Let's write this somewhere else. AlCl3. Okay, it's telling you that the relative molar mass is 267. Well, the thing is, you can see if you figure out, first you need to figure out what the molar mass of AlCl3, which is only the empirical formula, what it is, okay? So Al is 26, okay, that is not a 6. I've been dyslexic. Okay, 26.98 plus 3 times 35.45. Okay? And your answer should be 133.35. Okay? So what you do, this is clearly not the same as this one. Okay? So what you do is you need to find out how many times do you need to multiply this whole thing to get 267. So you put x, this is like an algebra type equation, and x would be 267 divided by 133.35, and your answer should be 2. Like, yeah, maybe it's not exactly 2, but it's around 2, like really, really close to 2. So what you need to do is multiply the empirical formula by 2, which should give you Al2Cl6. Okay? So yeah, that was fun. Okay. Number 17. Alright, for 17, it's asking you about calcium carbonate added to hydrochloric acid, and another equation, another like experiment where calcium carbonate is added to ethanoic acid, and it's telling you, okay, it's added at the same concentration, state one similarity and one difference. Okay? Well, you know that when you add calcium carbonate to hydrochloric acid, you're gonna get H2O, okay, and CO2. So you're gonna get bubbles, okay, bubbling, okay. And you know when you add it to ethanoic acid, you also would get CO2 and H2O. So that's a similarity, okay. The difference, okay, sorry. Can I just prove that my handwriting is not that bad? Okay, the difference is that the equation with HCl will react much more vigorously. How do you spell vigorous? Yeah, I don't know. Vigorously. Vigorously. Okay. I really don't know how to spell it. I'm ashamed to all IB students. Okay, like a disgrace, I mean. Okay, yeah. So I don't know why it reacts more vigorously. If someone knows, please tell me, because that's like something I really don't know actually. So yeah, that's your similarity, that's your difference. I got this from the mark scheme, so it's right. Like, I mean, you can just memorize it. Okay, so moving on. So you want to write an equation of the reaction between HCl and calcium carbonate. Okay, well, calcium carbonate and HCl gives you, it gives you CaCl2 plus H2O plus CO2. And then you need to balance it. So you just put, oh, what happened here? Okay, so you put a 2 there. Okay, I'm not going to go through all the balancing, like why you put a 2 there, because you guys get it. You guys are smart. You get it. Okay. Now it's telling you to determine the volume okay, so it's one of those questions again, where you have, okay, I'll do this one. I feel bad, I didn't do the other one. Okay, so you've got volume, you've got what is it, concentration, and you've got, oh, it's either volume or grams because it's giving you grams of calcium carbonate. And you've got number of moles. Okay, so again, I need to draw this in CV. Okay, so you copy everything from the question. It's telling you it wants the volume, but it gives you 1.5 for the concentration, and it gives you 1.25 for the grams. If you want to find out the number of moles for it, you go 1.25 divided by the molar mass, which we figured out before, which was 100. Okay, we can even do this without a calculator. We're that smart. Look. Okay, it's 0.0125. And then you do the little, you want to find out what it is here, so you go 2 times that divided by 1, which is 2 times 0.0125. Yeah, okay, this one I'm not going to do with a calculator. I mean, I will do with a calculator. I can't do it in my head. And your answer should be, wait, I don't know. Oh, sorry. Okay, I have to get a calculator out. 1 second, guys. Don't hate me. Please don't unsubscribe. Just wait. Promise I'll do this. 2 times 0.0125. Okay, so it's 0.025. Okay, moles. This is for HCl. Okay? Now we have moles and we have concentration. We can figure out volume. And because it's N over C, which is 0.025 over 1.5. Yeah, I'm not going to do this with a calculator. Divided by 1.5. And your answer is 0.0167. Leave it to 3 significant figures. Okay? I don't know why, but I do like 3 significant figures, even in math, so do that a lot. Okay? Yeah. Alright, moving on to the next one. It's asking you calculate the volume of carbon dioxide measured in, so it's giving you in straight away when you see kelvins and when you see pressure, you know that you're going to use one of the gas law equations, whatever. And so I think here, because it's giving you the grams of calcium carbonate, it means that they want you to figure out moles. Okay? I mean, wait 1 second. Sorry. Oh, this is of calcium carbonate. So they want to see how much of carbon dioxide is produced. Okay, well, actually, you can do this in a really simple way. Okay, which is, okay, you know that 1.25 grams gives you 0.0125 moles, right? And it's a 1-to-1 ratio, right? 1-to-1 ratio. So that means for CO2, wait, there's that thing here, it's really annoying. For CO2, you should get 0.0125 moles, okay? And you know that little law that says 1 mole of a gas at standard temperature and pressure, which is, this is standard temperature and pressure, you equals 22.4 dm3. Okay, so what you can do is say 0.0125 equals x, and again you do multiply and divide, and your answer should be equal to 0.28 dm3. So you can either do that, okay, which is really simple, really fast, whatever, or if you want to make yourself, your life harder, whatever. I don't know why people do that, but like some people like PV equals nRT, or like some people honestly forget about this, like this law, okay, which I've done actually a few times, and that was quite annoying because I had to do this long method, right? So what it is you put in it gives you the pressure, which is 1.01 times 10 to the power 5 V equals N, which you already know is 0.0125 times R. Okay, you know R is 8.314 times temperature, which is always in Kelvin. Guys, do not forget Kelvins, okay? And your answer is going to be, see, this is why I don't like this one. Your answer is going to be 2.8 times 10 to the power of -4 because it's in meter cubed. Okay? But it's acceptable, but don't forget that it's meter cubed. Okay? Whenever you're using this equation, it's meter cubed, okay? Which it's the same. It's the same answer. Like, don't freak out. Same answer. Like, it even kind of looks the same. But, like, it's just different units are used. Okay. Alright. Next question. It's asking you to write an equation for the formation of zinc iodide from zinc and iodine. So it'd be Zn plus I. You know it's a diatomic molecule. Do not forget. It's a diatomic molecule. Okay, so ZnI2. Okay, it's 1 mark, 1 easy mark. It's a nice mark. I like it. Okay, and okay, so this is a limiting, like a limiting reagent type question. Thank God. I like these ones. I actually like them. A lot of people really don't like them and get like really scared and like hate them and stuff. But like it's really nice. I don't know. I like it. What you do, is this our first limiting reagent one? I think it is actually. Okay, well anyway, I'll explain it. What it is the thing is, okay, you have like a little whatever, like if you're doing an experiment and you want to make zinc iodine, sorry, you put in zinc, you put in zinc and you put in iodine, and then what happens? But the thing is, you don't have, like, you just put in a random amount of zinc and a random amount of iodine, okay, and each zinc molecule, zinc, reacts with 2 iodines, right? To form zinc iodine. This is 1 molecule of zinc iodine, zinc iodide, sorry. The thing is, sometimes you're gonna, maybe you put an excess amount of zinc or an excess amount of iodine, whatever, okay? But sometimes the reaction will finish because one of these is limiting. It's like not enough, okay? So sometimes the reaction will finish and there'll be excess of one of these. So the question is actually just asking you which one is limiting and which one is excess. And you can find it really, really simply. It's like, it's really simple. I'll show you. What you do, okay, so you have the little equation here. It's telling you have 100 grams and 100 grams of each, okay, 100 grams and 100 grams. Okay, what I always do is I say if we had 100 grams of zinc, right, which is what we did have, theoretically, this is what I say in my head. I talk to myself sometimes during the exams. Okay, theoretically, how much iodine would we need? Okay, so what you would do is you take 100 grams. How many? You figure out how much it is in moles, which is 100 divided by. Wait, let's see what it is from 65.37, which gives you 1.53. Okay, and you see that it's a 1-to-1 ratio, so you would also have 1.53 moles. So theoretically, you would need 1.53 moles of iodine. Okay, but how many grams is that? Let's figure out to compare if we have enough. Okay, you multiply it by because you know the little equation. What is it? Mass, number of moles, molar mass. Okay. So we have the number of moles, and we can get the molar mass, which is Don't forget to multiply it by 2 because it's diatomic. Diatomic, people, don't forget. Okay, so 2 times 1, 2, 6.9. Your answer should be 388.314. So let's read this again. If we had 100 grams of zinc, theoretically, we would need 388.314 grams of iodine. How many do we actually have? Well, 100. So it means that we don't have enough iodine to react with the 100 grams of zinc. So iodine is the limiting reagent. The question is specifically asking, I said, oh my god. The question is specifically asking for which one is excess, which would be zinc. So say zinc is excess. And yeah, okay. It's really not that difficult. You can start with either one. I mean, you could have changed it and started completely differently and said, if we had 100 grams of iodine, okay, theoretically, how much zinc would we have? And you would get an answer that would show you that zinc is excess. Okay, the theoretically we would have less zinc than we put in the experiment. Or sorry, theoretically we would need less zinc than we put in the experiment. So that's why zinc is the excess one. Alright, you get it? Okay. Calculate the mass of zinc iodide that would be produced. Okay, this is a really good question because it covers a lot of things, okay? Thing is, you know that which one is limiting? It's iodine. So you can only determine how much product will be produced from the limiting reactant or reagent or whatever. Okay? Because obviously the excess one, like, you don't use the 100 grams to figure out of zinc to figure out how much of zinc iodide will be produced, because that's stupid. Okay? You use the limiting one always, because that's the one that's gonna end, and that's the one that's gonna determine when the reaction ends and how much of the product is used. Okay? So you take the, let's erase everything. Okay? Because there's a lot going on here, and it's just, let's not erase my triangle. I love my triangle. Okay, we don't even need this one. Okay, that's all we need. Okay, so 100 grams of iodine. Okay, you need to figure out how many moles that is. So that would be 100 divided by 2 times, what is it? Something like 100, oh yeah, 126.9. Yeah. And your answer should be 0.394. And it's already balanced, 1-to-1 ratio, so 0.394 moles of zinc iodine, what is it? Iodide. I'm so stupid. Oh my god. Okay. Of iodide, of iodide that will be produced. Okay. So how many grams? Because they're asking the mass. Okay, not the moles, mass. So it would be, wait, the mass. Oh yeah. So 0.394 times, you need to calculate the molar mass of this, which is 2 times 1912, what? 126.9 plus 65.37. Yeah? And your answer should be 125.75 grams. And this is for this question. So that's done and over with. Okay, question number 20. It's talking about, what is that? Sulfide, this is the equation. Okay. Oh, determine the limiting reagent. Okay, so I'm just going to give you the answer, okay, because it's a really long question, and Or should I do it? I don't know. Should I? Can I be bothered? I mean, we just did a question like it. Okay, the trick here, wait, let me just tell you what the trick is. You need to convert these two into grams, okay? Because it's kilograms. Who wants to deal with kilograms? Obviously not the IB, okay? So you you times it by 1,000, which is 1 times it by 1,000? Divided by 1,000. No, times it by 1,000. Yeah, times it by 1,000. Times it? Wait a second. Wait, if you have kilograms, it's 10. Yeah, you times it by 1,000 to get the grams, right? So I feel like, wait, I'm kind of dyslexic about this too. I swear, I need to get tested for it. I don't even know. Okay, wait. 1 kilogram gives you 1,000 grams. So 10 kilograms. Okay, so 1,000 times 10. Yeah, okay. So it's actually 10,000 grams. Yeah, it's a lot. And 5,000 grams here. So yeah, that's the trick for this question. Okay, and yeah, it shouldn't be that difficult. It's the same thing. The answer for this one, the limiting reagent in this reaction is Cu2S. Okay. Again, if you really don't know how to do this, like I really want you guys to do it by yourself so you get it and you don't just sit there and watch me. If you don't get it, then send me a message and I'll totally do it for you. Don't worry about it. Okay, for the next one it says calculate the maximum mass of copper. Okay, so again, don't forget, you always use the limiting reagent to figure out how much copper will be obtained. The answer for this is, let me tell you, wait. The answer, you should put it back into kilograms, okay? So it's 11.9 kg because the question was in kilograms. So you shouldn't like change it up however you want, you know, like IB is pretty particular about this. Okay? Okay, number 21. Okay, state and explain what would happen to the pressure of a given mass of gas when its absolute temperature and volume are both doubled. Okay, so I like these questions. PV over T, right? Yeah, okay. So again, do you remember what I told you? You're talking about pressure. So you would make that, you would equate it that way, okay? You put it like on one side, okay? And you see what happens. You double both the temperature and the volume, and then you know that it cancels out, simplifies, and it just, nothing happens to the pressure actually, because it still stays the same. There's no like extra ratio here, it's the same. So what would happen to the pressure? You would just say it stays the same. And yeah, this is your explanation. This is a good enough explanation if you show this part right here. That'll get you your 3 marks. Okay. Oh, this is just a typo. Forget it. This is the previous question that we did. I don't know what happened. Okay, number 23. This is the last question. See, I have all the answers here. Okay. Question number 23. Okay, it's asking you about calculate the maximum. Oh, look, okay, it's 5 marks. It's asking you to get the limiting reagent first so that you can calculate how much product, which is, which one exactly? Maximum mass of iron can be obtained. So, okay, I'll do this one with you, okay? So what you do is, it's already balanced for you, so that's great. It's telling you how many kilograms? It's telling you 30 kilograms, which is 30,000 grams. I don't know why they want us to work with the grams. Okay, and how much carbon is 5 kilograms, which is 5,000. Yeah. And you want to find out the number of moles. Okay, so if, just pick one, whichever one. So say, for example, if we had 30,000 grams of Fe2O3, how much carbon would we need? So what you do is you find out the number of moles again. So 30,000 divided by, you need to calculate this thing, the molar mass of this one, which is 2 times 55.85 plus 3 times 16. And your answer should be, okay, wait, 30,000 divided by 159.7. Okay, 1 second. 30,000. I'm doing this on a calculator right now. 1, 2, 3 divided by 159.7, and your answer should be 187.85. Okay? This is in moles. Number of moles. Okay? And so you want to find out the number of moles here for carbon. So again, do you remember what you do? Ignore this 5,000 for now. Okay? What you do is, oh, wait 1 second. Yeah. Okay. So remember, you have 2 moles of Fe2O3 plus 3 moles of carbon. Okay, 187.85. This is the reason I do this. Okay, you take this, times it by this, divide it this way. So 3, times whatever, you get it, right? 3 times 187.85 divided by 2. Your answer should be, wait, I'm doing it now. Should be 281.78. Okay? So this is the number of moles here. And you want to find out the mass you would get. So what you do, wait, what is it? Of Fe. So again, that little triangle, N mass, molar mass, right? Molecular mass, whatever. Same thing. I'm so tired. Okay, so you want to find out what? The grams. So the mass equals 281.78 times the molar mass of Fe. What's the molar mass of Fe? Okay, let's look at the periodic table. And Fe is 55.85. Oh yeah, we knew that. 55.85. And your answer is 15,737.32. This is grams. And clearly, it is much, if you had 30,000, so 30 kilograms of Fe2O3, you would need 15,737 grams of carbon, which you don't have. You only have 5,000. So carbon is a limiting reagent. Yeah? Wait, I have a feeling this is wrong. One second. Let me just check. Let's check the answers. 1 second. This is question number 23. And it says the Fe2, lovely. Alright, so it's telling me I'm wrong. Screw you. You're wrong. Alright, let's figure out what we did wrong here. Okay, sorry guys, I went back and I checked everything, my calculations, and I made a really, really stupid mistake and when I was doing this question. So I'm just going to do it right now without doing that mistake, because, yeah. Okay, so basically, Fe2O3, okay, it's okay, so it's asking, it gives you this equation, yeah? Yeah, that's fine. And it's asking you for what? The maximum mass of iron. of this. But in order to find out the maximum mass of iron, you need to find out which one's the limiting reagent, because that determines how much iron is made. Okay? Basically, it's telling you 30 kilograms, which is of this, which is 30,000. They actually penalize you if you use 30 kilograms, so use grams. And 5 kilograms, 5,000 kilograms, 5,000 grams carbon. Yeah? You know what, let me write this meter, because this is so messy. You know what? Let me show you. My writing is not that bad. Look, it's so nice. Okay. That's all we need so far, right? For now. You know, it's 30,000 here. And 5,000 grams. This is grams, right? What? Okay. Now you want to know moles. So if we use 30,000 grams of Fe2O3, how many moles would that be? Okay, so you know, so you go 30,000 divided by what? Divided by 159. Oh my god. 159.7, which is the molar mass for that. Okay? And you get, let me do this on the calculator now. So 30,000 divided by 159.7, you get 187.85. Okay? And if you want to find out how many moles that is for carbon, you know what you do? 3 times this number divided by 2. Because, you know, you're comparing the moles, right? The ratio. So you get 281.78 moles for this. Okay, so we want to see if what the number of grams is, if we had that many moles. So you would multiply, you know, the little triangle, N mass, molar mass. Okay, so you would multiply moles by the molar mass of carbon, which is 12. So times 12. That's what I made the mistake earlier. I didn't do 12. I did a different number. Some random number. I don't know why. Okay. So if you compare 3,381, okay, if you use 30,000, like the 30 kilograms of FeO3, which you did, how many grams of carbon would you need? Well, you need like about 3,000, and you have 5,000. So obviously this is excess, and this is the limiting reagent. So we need to use this number to figure out how much of Fe is going to be formed. Okay? So we know that 187.85 moles of this is going to be is used. So again, what you do is you go 4 times this number divided by 2. So 4, I'm doing it right now as we speak. 85 divided by 2. The answer is 375.7. This is for Fe. Okay, this is how many moles. But they're asking the mass. Sorry. What's the maximum mass of iron? Okay, so mass, you get it from moles times molar mass. So times Fe. Fe is what? What is it? What is it? Fe is 55.85 times 55. And your answer is this. Okay? Now you want to make it in kilograms. Remember I told you want to leave your answer in kilograms? So you divide it by 1,000, which would give you 1, 2, 3. So it would give you an answer of 20.98. Let's just check if that's the right answer. This is... Which question is this? Yeah, it's right. It's 21. Okay, so that's what they want. And wait, put down the kilograms so that they know what you're talking about. Okay, so that was painful. Okay. I don't know why I do this. I'm just such a kind person. I hope you understand quantitative chemistry. Please ace your exams, because otherwise my efforts would have been wasted, and that would suck, seriously. And yeah, anyway, good luck on your exams. Wish me luck too. And yeah, that's pretty much it. Alright, bye guys. Follow me and subscribe and all that stuff. Okay, bye.